Welcome to Lecture Online. In the following videos, we will explain you how to solve a numerical on velocity and acceleration. Okay, now to start with, we will understand how to draw a velocity diagram. So we'll start with understanding what is a velocity. Before that, let me tell you that this velocity diagram right now I'm trying to explain you is by what is called as the relative velocity method. There are other methods like Raven's method and the instantaneous center method. So in this video, I will show, this is related to how to draw the vectors for the vectors by relative velocity method. Now, let me tell you with an example. Here is a person walking. When I say is walking, that means he is moving with some velocity and he has got some direction. So let me tell you that he is moving at a speed of 2 meters per second and he has got this direction. There are two attributes here. One is the speed at which he is walking and the other is the direction to which he is walking. Of course, a person need not have to walk in a straight line, but at an instant, at a point, he would be walking in some direction. That direction is this. So, since he has got both direction and magnitude, and this could be represented as a vector. When I say a vector, vectors are basically an arrows like this, where the length of the arrow would actually give the magnitude of the velocity, and from the tail to the head of the arrow shows the direction in which this person is moving. And instead of moving at 2 meters per second, if he is moving at 1 meter per second, and the length of the arrow would be exactly half of this size. So we can draw these arrows proportional to the quantity of this, or we can say the magnitude of the velocity. And here, when we mention the vector, we need to understand few things. So for that, let me call this person as P and is walking on a ground G. And when I draw a vector always has a starting point, which is the reference point, which is not moving. So therefore, the reference point which is not moving is the G, and with respect to G, the person is moving in this direction, and his magnitude is shown with this length of this arrow mark. And this is the velocity of the person, and this is actually 2 meters per second. This length of the arrow represents 2 meters per second. And when I say this 2 meters per second, this is the velocity of the person with respect to ground. So the first suffix represents, the P represents the point which is having a velocity with respect to a reference point G. So when I say this, when I got two suffix, so the first suffix refers to the point which is moving and the second suffix is to the reference. So since the reference is fixed, not moving, we can as well write this as simply Vp. So when I got only one suffix, you can understand that you are referring to what is called as absolute velocity. Absolute velocity. Okay, now the relative velocity can be understood by one more example. Let me tell you this. So instead of this person walking on the ground, let him be doing a small stunt moving on a train, and which is also moving. This is the train which is moving, say at 20 meters per second, and this person is trying to run on this train like this at a speed of 5 meters per second. So if you can understand the scenario, the train is moving with respect to a fixed ground, and it has got 20 meters per second, and that this person is trying to move this. So if I want to draw a vector diagram for this situation, then I start with a point G which is fixed, and the speed of the train could be drawn with a vector like this, which represents 20 meters per second. So this is the speed of the train. So if I call this train as T, it is the speed of the train with respect to the ground, and I need to show this as small g. I need to show this as small t. So now with respect to this train, this person is also moving forward. So his speed is 5 meters per second. So you can see that the length of the arrow here, since it is 1 by 4th of 20, the length of the arrow should be 1 by 4th of this 20. So of course it may not look as per the scale here, but I have shown it as if it is smaller than this, so it is actually 1 by 4th of this size. So this refers to the velocity of the person, so I'll mark this as P here. So this 5 meters per second is the velocity of the person with respect to the train, and this to 20 meters per second is the velocity of the train with respect to the ground. So if you want the actual velocity of the person, with respect to the ground, then you need to draw a vector right from this ground to this person like this, and you will get a vector which is as long as this. So the vector length is proportional to 25 meters per second. So this is how we can actually add and deduct vector. So if I want to explain you how to deduct vector, let me take this same person. Instead of going in this direction, if he is trying to run in the opposite direction, then what would happen? So instead of adding this, he would be in the opposite side here. So 20 meters per second this side and 5 meters per second this side. In this scenario, the person is running opposite to the direction of the train. If I want to draw a vector diagram for this, so let me draw, this is the ground on which the train is moving. So I should draw a vector starting point, which is the ground, which is the reference point. I should mark it with small letters here. But then the direction of the train is this side. So proportional to 20, I'll multiply this by 2 and make it as 40 mm. 40 mm here, which is proportional to 20 meters per second, and then this is the speed of the train. So this 40 mm per second is proportional to 20 meters per second. So this 20 meters per second is nothing but the velocity of the train with respect to the ground, and the person is running 5 meters per second in the opposite direction. So you need to draw one arrow in the opposite direction. This arrow in the opposite direction is the velocity of the person with respect to the train. So the final ending point of the arrow is this, and if you want the velocity of the person with respect to ground, so you should now measure the distance between this ground and the person. This is the point where it is the velocity of the person. So measuring this, you can understand that, so out of 20, 5 is gone. So the velocity of the person with respect to ground is 15 meters per second. Okay, in the earlier case it was 25 meters per second. Let us now understand a scenario where there are two bodies which are moving related to each other and they are not moving in the same line. So imagine this is a truck which is moving in this direction, which has got a velocity of 10 meters per second, almost the speed of Usain Bolt. And here is a bike which is trying to go like this, and this is moving at double the speed of the truck, and this direction is going this direction. Okay, I'm showing it behind. Okay, it makes no difference, the arrow is shown behind here. So this is going at 10 meters per second this way, and the bike is going this way. And now to draw the vector, so first I can actually locate this as the ground, some point on the ground. So let me draw the point ground here. Ground is G. I can write it as that's with small letters G, and then let me write this as the velocity of the truck. The velocity of the truck is 10 meters per second. So proportional to 10 meters per second, I have drawn a length maybe 2 centimeters. And now with respect to ground, this biker is moving at 20 meters per second in this direction. So he is going like 20 meters per second like this. So I will mention this as the velocity of the truck. This is the velocity of the biker B. Now you will see that if the biker observes the truck coming, and what is the speed at which the biker will see the truck approaching towards him. Suppose if he is standing exactly on the ground, he will assume, okay, can see that it is approaching him at 10 meters per second, but here he is also moving like this, and the truck is also moving. But suppose if it is in the opposite direction, we could have added it. So that is, we could have added that the bike, suppose if the bike was coming like this, suppose the bike was coming like this at 20 meters per second, then like the previous case of the train example, we would have added that both the biker would see the truck approaching him at a speed of 20 plus 10 meters per second. Now, this is a case where these two are not in the same line. So, what is the speed at which the biker will see the truck approaching him? Now, to know the velocity of the truck with respect to the ground, this is the vector. To know the velocity of the bike with respect to the ground, this is the vector. If I want to know the velocity of the truck with respect to the bike, so then the vector should start like this and it should go like this. So this gives the velocity of the truck with respect to bike, VTB. So this is actually the velocity of the truck with respect to ground. This is the velocity of the bike with respect to ground. If you start from this point, this is the velocity, the second is the reference point, and the first suffix is the point whose velocity is being measured. So this is the velocity of the truck with respect to the bike. So you'll understand that, looking at this arrow, you'll understand that this is this is definitely more than 20 meters per second, and therefore if you measure it, it may come around to 23 meters per second, which means that the biker would see that the truck approaching him at an angle of this and at a speed of 23 meters per second as he is actually trying to move like this. And the same thing could be seen by the driver of the truck, and the driver of the truck would see the bike approaching him. If you want to know the speed of the bike with respect to the truck, so then you should draw an arrow mark in the ulta direction like this. So this would give you the speed of the bike with respect to the truck. So the truck driver will see the bike approaching the truck, and it will be in this direction, it will be the same value. So both this biker and the truck will see each other approaching at the same velocity, but exactly in this opposite direction. The direction is this. So you can draw this to a scale, and you can measure this vector length and then convert back to scale to get the actual value. This is how you find the velocity, the relative velocity. Now we'll see how to represent a velocity of a particle or a body which is moving about a fixed point and which revolves around a circle here, along the circumference of the circle here. So imagine, so these are definitely very useful because most of the mechanisms have got links which are rotating about some point, and you need to know the velocity of one end of the link which is rotating about the other hinge point. So this is definitely useful. So imagine this link which is actually revolving about this hinge, and thus let this link have a radius r, and the end of the link is p, and you'll see that as it revolves in this direction, so maybe at some velocity, so you can call this as 1 round per second, and 1 round per second or you can call it as 60 rounds per minute. Otherwise, if you don't want to call this like this, so then you can call it by radians. You know that once it rotates by one full rotation, so this is actually 2 pi radians. So if you rotate half, it is actually pi radians, so 3.14 radians, and if you rotate twice, it is actually 2 pi radians. So 2 pi is nothing but 6.28 radians per second. So 1 RPS has to be multiplied by this 2 pi to get this. So in the examination, maybe the RPS is given or RPM is given, and then you need to convert this into angular velocity omega, and this omega has to be in terms of radians per second. So how do you do it? You multiply the RPS by 2 pi to get this radians. If it is given in RPM, multiply by 2 pi and again divide by 60. So the omega is given, the radius is given. Now to find the velocity of the point P, about the center of revolution, then you know that the velocity is definitely given by the equation v is equal to r omega. V is equal to r omega. And now to actually now to get this equation, let me tell you what is actually radian. So one radian is basically the angle subtended. Suppose if it is the radius, and if you draw an arc whose length is equal to radius, the angle subtended here is called as 1 radian. And for a semicircle to be drawn, you will need 3 such radius to complete, like 3, and remaining is 0.14 radians. So if some body moves along the circumference like this, then it will move around a distance of 3.14 radius, whose length. So therefore, if it moves one round, then it will rotate by 3.14 into times of this radius. So it is the reason this r has to be multiplied with this omega, which is actually this 6.28, to get the velocity. So this is basically the circumferential velocity. So v is equal to r omega. So this is v, which is r into omega, and you'll understand that the velocity should be always perpendicular. There is no way that the velocity can be other than perpendicular. When I suppose if I show a velocity is like this, which means that this point is moving towards inside, which means that the length of the link is decreasing. And also if it moves like this, the length of the link is increasing. So it cannot be, it is not possible. So therefore this point on a rigid link should always move perpendicular to this. So for a body which is revolving about a point, so you need to find the velocity, which is given by r omega, and the direction is perpendicular to the link. So these two things you have to remember. The first thing is that v is equal to r omega, and the velocity of that point is perpendicular to the radius about which on which it is rotating. So this way. Again, how do we represent the velocity of the point P here? So this point P is moving about a fixed point O. So this point O has to be written as a fixed point here, and then this velocity direction is this, and the length of the arrow is proportional to r omega. So like this, the velocity vector has to be drawn, which is proportional to r omega, and it should be drawn in the direction, the instantaneous direction at which it is, at which you want to show the velocity, like this. So the velocity has to be shown like this. So I can give a better example. We all love cricket, and you know that when a bowler bowls a ball, and when he is about to deliver the ball from his hand, and the ball would move perpendicular to his arm, and this is the arm, this is the head of the bowler, and he is just about to deliver this ball, and this ball moves perpendicular to his arm, unless he makes any, suppose if it doesn't make any wrist action, if he just releases the ball at this position, it will move perpendicular to this, and the speed of the ball would be definitely equal to the product of the radius of his arm, the length of his arm, which is the radius right now, and multiplied by the angular velocity omega. So this will be r into omega. Now to get a feel of this equation, v is equal to r omega, let us consider that when the bowler bowls, so it is his shoulder and it is his arm, and he is trying to release the ball here with his arm, and let this length be 1 meter. Of course it is almost around 1 meter, and let his arm revolve at a speed of a very slow speed, 1 revolutions per second. So of course he doesn't have to revolve it completely, but at the speed at which he is revolving about this point, he would cover 1 round in 1 second. So one round is nothing but 2 pi. 2 pi is 6.28 radians per second. So if you want velocity, it is r into omega. So r into omega, so r is 1 meter, and this is 6.28 radians per second. So you get it as 6.28 meters per second. So velocity is 6.28 meters per second, which is a very slow speed. So you can almost say that the speed in terms of kilometer, 6.28 meters per second. So if you want it per hour, you multiply it by 3600, so you get it as 22,608 meters per second. So 22,608 meters per second, or if you want it in kilometers, it is 22 kilometer per 1 hour. Sorry, this is 22 meter per hour, sorry guys, because we multiply it by 3600. So we are getting this per hour. For 1 second it moves by so much, multiplying it by 3600, you get it as so many meters. 22,000 meters is nothing but 22 kilometer per hour. 22 kilometer per hour is a very, very slow speed for a bowler. So the bowler should be almost bowling at maybe around 3 RPS. So if it is at 3 RPS, so you would feel that R is the same, the arm length is the same, angular velocity instead of becoming 6.28, it will be 6.28 into 3, because it has multiplied the velocity, the angular velocity has got multiplied by 3. So this becomes 66 kilometer per hour, which is still not a very good speed. So if he actually bowls 4 times, it is 88, and if he suppose if it is more than that, it could be more than 100. So in that way, of course, here to represent the velocity of the ball, we can show like this. So now the velocity vector could be shown like this. How? So this is the person, the shoulder of the person. So the person is bowling the ball, and we'll start with the vector showing like this P, and the vector, the ball is released like this, and the length of the vector will be proportional to this. Either it is suppose if he is swinging his arm by 3 revolutions per second, so this will have a velocity of 66. So 66 can be taken as 66 mm, and you can draw a vector, and this is the velocity of the ball. So the velocity of the ball, I'll write it as B. So this is the velocity of the ball with respect to the person. Of course, why I'm telling it as the person, because the person is releasing the ball. And now imagine the person himself is actually running. Suppose the person himself is running while he is releasing the ball. He is running at around, suppose if Usain Bolt was to bowl a ball, he would be running at 10 meters per second. Imagine he is moving at a speed of 10 meters per second. Then what would happen? So here both the velocities would get added. So this person would be moving at a speed of 10 meters per second in this direction. So if I have to draw this vector, then it would be like, now bowling the ball trying to revolve his arm 3 rounds per second would give a velocity of 6.28 for 1 round, and 6.28 into 3 approximately around 18.8 meters per second. That would be the velocity of the ball thrown by the arm, and that is with respect to the person. If I have to draw the vector considering both the person running with respect to the ground as well as the ball being thrown from him, you have to draw 2 vectors. One is with respect to the ground. So this is the fixed point ground, and the person is running at a speed of like 10 meters per second, which is a very good speed. This is the average speed of Usain Bolt. So 10 meters per second. So this is the velocity of the person. This is the velocity of the person, P, and you can say this is the velocity of the person with respect to ground, or simply call it as velocity of the person, because ground is not moving. So you can, it is the relative, it is not the relative velocity, it is the absolute velocity. Now with respect to this person, this ball is moving at an inclination. Of course, he is not throwing, throwing horizontally. He is now throwing at an angle like this. Of course, that's in cricketing terms, people call it as releasing the ball at 11 o'clock position and so on. So he's trying to release the ball at some position like this. So if this is 10 meters per second and he's trying to release the ball at a speed of 18.85, proportionately we can draw a vector like this, which is proportional to 18.8 meters per second. So this is the speed of the ball. This is the speed of the ball with respect to the ground. So if you want the speed of the ball with respect to the ground, then what you have to do is you'll have to draw a vector like this. This will give the speed of the ball with respect to the ground. this will give you the speed of the ball with respect to the person, and this is the speed of the person with respect to the ground. Like this, the velocity vectors are drawn, and these are called as velocity diagrams. These are called as velocity diagrams, which will help you to find the relative velocities. Here you can see that what you are showing here with respect to the ground, all these are absolute. This is absolute velocity because it is measured with respect to the ground. This is the velocity which is measured with respect to the ground. So this is absolute velocity, this is absolute velocity, but this is the velocity of the ball with respect to the person. This is not with respect to the ground, so this is called the relative velocity. So this is the meaning of relative velocity and the absolute velocity. So by this diagram you can understand that this vector would be definitely more than 18.8. Of course it is not exactly the sum of 10 into 10 plus 18.88. It will not be 28.88 because it is not the summation along the line. It will be less than that, so it can be like 27 meters per second approximately. Of course we can draw an exact vector diagram here to show this. So like this we can find this. So in the next video we will try to solve problem on a slider crank mechanism to show you the use of this velocity diagrams.